Good morning, students. On today's lecture, I'll cover one of the topic. This is more like a observation or finding out how this thing actually looks or behave. Okay, Pythagorean theorem, but without the square. In my last video, I have showed you that what this right angle triangle means, and then Pythagoras theorem works with this square, that this each of the line that form, okay, it makes a square. It's a bigger square, and other two sides make smaller square, and sum of these two sides, the square they form, sum of this areas of two squares equal to sum of this bigger square. Area of the square opposite to the hypotenuse equal to sum of other two sides square. Okay, but that time I ask you, what if it's not square? If we have another areas, how it's gonna behave? Are we gonna have the same formula such as hypo square equal to sum of other two sides square? I have drawn some of the shapes for you. This is all of this triangle, right angle triangle. You can see that this is a right angle triangle, this is a right angle triangle, this is a right angle triangle, and this one we have done before with a square. Okay, all these triangles have hypotenuse equal to 5 centimeter, and other two sides, the bigger one is 4 centimeter, this is 3 centimeter. Okay, now is this gonna work? This is an equilateral triangle. That means all sides are equal over here. Let me just do this. This side, this side, this side, they are all 5 centimeters. Since this is 5, this is 4, this is 3. These are all 4 centimeter each, and these are each 3 centimeter. Okay. Over here, this is the semicircle. So diameter is 5 centimeter. This diameter is 4 centimeter. This diameter is 3 centimeter. And this is a regular hexagon. 1, 2, 3, 4, 5, 6 sides, regular polygon with 6 sides. So it's hexagon. And this side is 5 centimeter, 4 centimeter, 3 centimeter. Okay, and that's 5, 4, 3. And I'm not gonna talk about that. If I draw things like that, is it gonna work the same way? Let's see. Okay, let's start with the first one. Okay. Now I have this first one. It's a again right angle triangle over here, and I have this an equilateral triangle of side 5 centimeter. Okay, and this one is 4 centimeter. Actually, this is smaller than that. Make this one 4 centimeter. This is 4 centimeter, 4 centimeter, 4 centimeter, 4 centimeter, and this is 3, 3, 3, 3. Okay, and that's the, oh sorry, I meant to draw equilateral triangle. Okay, so that's 3. Sorry about that. Let me redraw that. Okay, sorry about that. I'm extremely sorry about that. Okay, that's triangle ABC. So this is 5. This is 5 centimeter. This is 4 centimeter, and this is 3 centimeter. So the triangle I'm drawing over here, that's gonna having all side equal. So these are equilateral triangle. This triangle is equilateral triangle, and over here I'm gonna have another equilateral triangle, but this time the side is gonna be 4 centimeter each, and this side I'm gonna have another one with 3 centimeter each. Okay, now equilateral triangle, the properties of equilateral triangles, since all sides equal, all angles are equal, and each angle is 180 divided by 3 equal to 60 degree. So this is 60, this is 60, this is 60, and all of this over here, let's say this one, this is 5. So this is 5, this is 5, and name this one area 1, area 2, area 3. And what this formula of Pythagoras theorem, if I had the way I have drawn, if I have, let me draw it over here, and then A, B, C. So B of is the hypotenuse, and A over here, C over here. So B square equal to A square plus C square. Okay, this is our basic formula. Okay, now over here, area 1, that's gonna be, I hope you know that area of equilateral triangle is gonna be half length into length. Okay, let me write down the actual formula. If this is A, this is B, and this is theta, so area of this triangle is going to be half AB sine theta. That's our basic formula for the area when two sides and included angle given. Now these two sides, each of them are 5 centimeter. So I'm going to write down this 5 square, and this is going to be sine 60. So 5 square is 25. So this is going to be 25 divided by 2 sine 60 degree. I'm not going to write down sine 60 equal to root 3 by 2 or using the calculator. I'm going to keep that for the time being like this. And area 1, I already have that. So area 2 plus area 3 according to this formula. Okay, I'm going to see that if these two are equal or not. So area 2 is going to be same way. This is my area 2. So half like that 4 square sine 60 plus for this one half 3 square sine 60. Now you can see that sine 60 common and half common. So if I take half common and sine 60 here, and in between I have 4 square is 16 plus 3 square is 9. So that's going to be 16 plus 9 is 25. So 25 divided by 2 sine 60. Now these two are equal. So whenever I have equilateral triangle, it's true for this one. Okay, because remember the Pythagorean theorem, what does it mean? Area of the square opposite of the hypotenuse. So it's instead of square, area of the shape, okay, of the opposite to the hypotenuse equal to sum of areas on the other two sides. Okay, so these two sides areas, summation of that equal to that. So it's actually give us the exact formula for that one. Okay, let's do this one. Okay, this diameter is 5, so this radius 1 supposed to be 2.5, and let's say this is area 1, this is going to be area 2, this is going to be area 3, and for area 1 the diameter is 5 centimeter, therefore radius is going to be 2.5 centimeter. And you know area of a circle is pi r square. Now semicircle, area of semicircle is going to be half pi r square. Now area 1 is going to be half pi, r is 2.5, so it's going to be 2.5 square. Let me use the calculator for that. So 2.5 squared, that's supposed to give you 25 by 4 divided by 2, that's 2, so 25 over 8 pi square centimeter. Okay, and area 2 plus area 3. Now area 2, that has radius supposed to be, diameter is 4, so radius supposed to be 2, and over here radius supposed to be 1.5. This is 1.5 and that's radius is 2, 1.5. So that's going to be half 2 square and then pi plus half pi and then 1.5 square. Same way if I take half and pi common, okay, so I'm gonna have half pi and over here is 4 and over here is 1.5 squared, that's gonna be 9 by 4. Okay, 9 by 4 plus 4, that's give me 25 by 4 divided by 2, so that's 25 by 8 pi. So this is also proving that Pythagoras theorem works if instead of a square I take semicircle. Okay, now last one is this one. I think you got an idea that it's gonna give you the same result, area of this equal to sum of area of this. Okay, so that's what it is. I'm not gonna do this one, but I'm gonna do something else. Okay, let's say when we prove that this is okay, that area of the shape opposite to the hypotenuse equal to sum of areas of the other two sides. Okay, is this gonna be true for if we draw any shape? Let's say instead of that, if I draw a rectangle, okay, a rectangle, let's say this is the rectangle, it's 5, rectangle length is 2, then this is 3, and rectangle's length is 2, all of them I'm taking length 2, okay, and this was 4. Will it gonna work? Again, area 1, area 2, area 3. So what is area 1? Area 1 gives me, see, 5 times 2 is 10, okay, length into breadth. What about area 2 plus area 3? That's going to be 3 times 2, that area of 3, and area of 2 4 times 2. So that's 6 plus 8, that's going to be 14. Now we have an interesting concept. It doesn't work for rectangle. It does work for equilateral triangle. It does work for semicircle. It's going to work for this one, okay, but not for this one. Then what we are doing wrong, okay? Why it's not going to working? Now this thing is, look at this. They are not similar diagram. Square, whenever you see the square, 5 and these are some kind of similar diagrams, okay? Square always similar, circle is always similar, quadrilateral always similar, okay? Then regular, pentagon, hexagon, whatever you have, they are similar. But this one is not similar. Similar is corresponding sides are proportional. So 5 divided by 2 for this one is 2.5. But over here 3 divided by 2 is 1.5. They are not equal. Okay. Now when it's not like that, then it's not gonna work. Now let's see with this one. I had this the shape I have over here is, let's say 5 divided by 5. Over here 5 divided by 5 equal to 1. Over here 3 divided by 3 equal to 1. 4 divided by 4 equal to 1. They are corresponding sides are proportional. Opposite of this one, opposite of that one, they are equal. Okay, the proportional. Okay, but over here 5 divided by 2 is 2.5. 3 divided by 2 is 1.5. 4 divided by 2 equal to 2. All of them are different. So can we do something different? Let's say if I have 5 divided by 2 equal to 2.5. Okay, if we can keep it like that. Okay, so for this one, area 2, let's take this one, 4 divided by something. It's supposed to make 2.5. Okay, so what is that A equal to? So 4 divided by 2.5, it's supposed to be 8 by 5. So instead of that, instead of 2, if I take 8 by 5, for the timing, think about that. That's for area 2. Okay, and for area 1, take that area 3, that's 3 something B, and ratio has to be equal 2.5. So B is gonna be 3 divided by 2.5, 3 divided by 2.5, and that's gonna give me 6 by 5. So instead of this 2, I'm gonna take 6 by 5. Now let's try that. Area 1 as it is, 5 times 2, that's gonna be 10. Okay, now area 2 plus area 3. Now area 2 is 4 times 8 by 5, and area 3 is gonna be 3 times 6 by 5. Now let's see how this thing works. 4 times 8 by 5 plus 3 times 6 by 5. Now that's gonna be 10. Okay, so when the corresponding sides are proportional, then it's gonna work. Now we can conclude that Pythagoras theorem will be true if we are having the similar shapes on each of the side. Okay, it can be congruent. That means equilateral, not congruent, similar. Let's talk about similar. Similar and congruent is a little different. Similar, let's say 2 triangles are similar if all their angles are equal. This is one of the proof, okay, to be similar. If they are similar, the shapes are similar, it's gonna hold the Pythagoras theorem true. But if it's not similar, like the example I have given, 5, the dimension was 5 times 2, dimension was 4 times 2, and dimension was 3 times 2. This one was not the similar shapes, so it didn't work. The Pythagoras theorem didn't work for that. But as long as you have similar shapes, you can say that similar shapes, or you can say regular polygon. Okay, this one is your polygon. Okay, polygon means enclosed space with a straight line. So if this is polygon, then it's gonna work. This is polygon, it's gonna work. And this is not polygon because one of the side is, in this particular case, one of the side is not a straight line. So this is not a polygon. These are similar shape. Okay, all of them are similar shape. You can see that all these circles are similar shapes. Okay, so whenever we are taking anything like that, okay, it might be similar, depends if the ratio are the same of the diameter. Okay, so similar shapes or regular polygon, if it on the sides of each of the side of the right angle triangle, then Pythagoras theorem gonna be true, okay, for each cases. But if it's not similar, it's not gonna work. Okay, thank you for watching. I hope you like that. If you don't, please leave it in the answer box that how I can improve that. But the aim of this video was to make you think that how this thing works. Okay, think about it whenever you come up with a mathematical theorem or mathematical concept. Okay, whatever you have learned, just with that knowledge, try to think about it, how this thing works. Okay, I hope it's going to help you in other subject or other field of your knowledge. Okay, thank you very much for watching. Take care. Have a good day.